Okay, pre-calc. We're in review mode. So even though it's review, write it down. And we had a list of things to study from. And we're reviewing this on Thursday. Alright, one thing that wasn't on the list that I should mention is finding logs to other bases. I don't think I had that on my list. If I did, I forgot. So you have to sit through a repeat. Logs, taking logs to other bases. So for example, if you had log to the base 5 of 14, and I asked you to find that number, this is saying what exponent do I give 5 to get 14? Well, if I give the 5 the exponent of 1, it's worth 5. Too small. If I give the exponent of 2, 5 squared, I get 25. Too large. So it's somewhere between 1 and 2. So I need to turn to the calculator to help me get it exactly. And so we learned how to get this into our calculator. Most of our calculators do not have a log to the base 5 capacity. It only has log base, which is base 10, and ln, which is base e. Now if you have an nspire, it has the capacity to actually just type this in. Alright, but until we all get those, we are going to do it this way. So we're going to take the log of the high number over the log of the low number, and this is an log. We do have that button on our calculator. It is base 10, or we could use ln of 14 over ln of 5. They will give us the same answer. Alright, so just a review on how to take logs to other bases that aren't on your calculator. Alright, now I'm going to look at how to solve exponential equations. To solve an exponential equation, we will first find one. So an exponential equation looks something like this. Like say we have 3 times 5 to the, let's see, I want one that comes out fairly even. X minus 1 equals 21. Alright, so you know it's an exponential equation when the exponent, that says x minus 1 by the way, when the exponent, the unknown, is in the exponent. So to do that, first you want to isolate the term that has such an exponent. So I want to move the 3 over, and that's by division. So that leaves 5 to the x minus 1 equals 7. And now I want to work with this x minus 1, but I want to get it out of the exponent. So I've learned to do that. I'm going to take the log of both sides. What log base should I use? We're going to match this number. So we're going to take log to the base 5 on both sides. It has to have the same base on both sides. So this is saying, what exponent do I give 5 to get 5 to the x minus 1? And that's just x minus 1. So I have brought this down where I can use it. And over here, log to the base 7 over log to the base 5, like I did up here. We'll have to come up with a number. Log, say 7 over log 5. And then we'll add a 1 to each side. When it says solve, your last step says x equals. So you can tap out log 7 over log 5. And then moving the 1 over. Whatever that number is the answer to our problem. So that's the type of thing we do with exponentials. And then we have solving log equations. Hasn't been that long ago that we did this. Again, solving means you're going to find out what the unknown is. So let me do one. Suppose I do ln of the square root of x plus 2 equals 1. Alright, so we will start with that. We learned that to get rid of an ln, we have to exponentiate both sides. So we're going to make this to an exponent of some number and this an exponent of the same number. What number should we put these as exponents to? It's always going to be the base of the logarithm that we're working in. ln is base e. So I'm going to take e and raise it to this whole thing. E to the ln, that's base e, square root of x plus 2 equals ln of, oops, this is an exponent. Sorry, exponentiating it. So this becomes the exponent of e. Alright, so over here I'm raising e to the number that you raise e to get square root of x plus 2, which is square root of x plus 2 equals the number e. Again, I'm trying to solve for x, and I square both sides, and I get x plus 2 equals e squared. Move the 2 over. X equals e squared minus 2. If you want a better picture of what that answer looks like, you can tap it into your calculator, but that's an exact answer, and I'm well pleased with it. Alright, when we went on from there, we learned continuous exponential growth. And that looks like this. The amount at some time t equals a sub o e to the kt. And all I want to say about that, since we were just working on it so recently, is find k, and there'll be a statement, and you'll use that statement to put in values here, here, and here, and you'll use some of our skills from solving exponentials in order to solve that for k. And once you get k, so you'll find k and use k. The second part will have a question where sometimes they leave this off and they give us this, we know this, now we know this, and they'll give us this. And sometimes they leave off this and give us this, this, and we know this. And we solve for that. So it depends, we're going to use the k to find what is asked for. So population growth is a typical one. Decay, chemical decay is another one. They all use this kind of exponential growth. Alright, so let's see what else. There were some other log models that we looked at. One was called logistic models, but that was very recent material, so I'm not going to do one. I'll just mention it starts slow, then it grows quickly, and then it levels off. And you get an equation for that, and it has an e to the something in it. And we had the Gaussian curve, called the normal bell-shaped curve. Also, it looks like this. And the equation allowed us to find the average value right here, looking down at this x value. And then there were some other log models. There was some dealing with earthquakes, so you might look over those, where they had the Richter scale was logarithmic, and also the pH of a liquid is also a logarithmic relationship. Alright, again, I'm not doing a whole lot of specifics, a little bit, to carry you through the rest of the topics on our list. So we'll have those to work on in class to get us all ready for the test. Okay, I'll talk to you soon. Good night.